let's start exercise 4. I've got some of the string. It's the thick yellow one that we used before in the semester. This actually makes the wave nice and visible. And what I'm going to do is I'm just going to take about 1.5 meters of this and then measure its mass. So what I'm going to do now is just stretch it. You can't see what I'm doing. Here's 1 meter, and then I've got 1.5 meters. So let's snip it. All right, so I have 1.5 meters of the string. Let's go over here to my sensitive scale. So what I want to use is the most precise scale here. So it's a little, it's got a little, not 0 on it. Oh, now it's going the other way. Okay, now it looks good. I'm going to try and roll up my string and put it on there. Okay, how am I going to put the string on here? Let me just loosely tie it on my fingers. So I want it to sit the entire thing. There we go. All right, so we have, excuse me, the mass of the string, 0.793 grams. 0.793 grams. So let's figure out what the mass density is really quick. We got 0.793 grams, and remember what I said, how long it was? 1.5 meters. So the mass is 0.793 grams, and then plus or minus 0.001 grams. Now, how do we, I've got to change it to kilograms. Just look at this. What does that equal? Well, you got to move the decimal point over by 3. It actually 0.000793 plus or minus. Okay, so this is how you write it down in your data sheet. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 1. So how I figure that out, and once you convert it to kilograms, you got to go in the very last digit. So that's 1, 2, 3, 4, 5, 5 zeros, 1, 2, 3, 4, 5, and then put a 1 there. So the mass, 0.000793 plus or minus 0.000001 kilograms. I know it sounds, it's very precise, hopefully it's accurate too. So 1.5 meters, that's fine. Now, linear mass density is represented by mu. It's a type of density. You're used to, in the very first lab, we found volume density, which is mass per unit volume. Linear mass density is mass per unit length. So it's still a mass density. Instead of doing it by volume, we're doing it by length. And for a string like this, it's not very useful to measure the volume of a string because it's so tiny. The radius is so small. The volume isn't going to be, it's not useful. For anything that's really, really long like this and skinny, whenever you're doing physics or looking at it, the better way to look at it is the linear mass density. Now, if you have something like this piece of paper, which is thin but has a large area, you'd use the area density, which is mass per unit area. So here we're going to use the linear mass density, not the area or the volume mass density. So again, just divide the mass by the length, and you should get your answer. So 0.000793 divided by 1.5. So you write that down in your data sheet.